Hello, my dear students and the rest of the learners. Welcome to part 9, section 1 of 2 in C++ computer programming series, in which we are going to learn about introduction to arrays. My name is MemGM, or you can simply call me Emily Swap. An array is a data type that consists of a set of objects called elements, all of which are of the same type and are arranged contiguously in memory. This array is then given a symbolic name for identification. Therefore, arrays are suitable for representing composite data, which consists of many similar individual items or elements, such as list of names, scores, etc., as long as they are of the same type. It can also be said to be a vector, a table, or a matrix, depending on the number of rows and columns that it has. Therefore, array elements can be of any type in C++, but not a combination of more than one type. Such data types can be integer, long integer, double, float, char, amongst the others. For example, if the elements being stored in memory are students or student scores or a score in 5 subjects, the array will have a symbolic name such as student scores for a single student or student scores for the several students, whereby all the elements in it can be of type integer. In other words, my dear students and the rest of the learners, the way we name variables is the same way that we name arrays. In this case, the name or names of the student or students or the names of the subjects done are not included in the storage. In other words, what we are saying is that when we are dealing with arrays, if you are storing numbers, that is data of type integer, you only store integer. If it is char, you only store char. So you don't mix the types. And therefore, even if you are to enter or store scores that have been attained by several students, what is going to be stored is only the marks, the whole numbers, or marks which have fractional parts, but you cannot include any other type, such as the name of the student or the name of the subject. In this case, it is the user who will be aware of the owners of the scores and the names for the exams whose results are being stored. Otherwise, if the name or names of the students or the names of the subjects or exams are to be included in the storage together with the scores attained, that will be a different data type or data structure, because that is a combination, or you are storing data which is a combination of several data types. And that type of data or that type of data structure, we usually call it struct or structure, that we are going to learn in part 10 of this series of tutorials. If, for example, you wanted to compute the total marks that a single student has attended in 5 exams, you would then have to declare an array that would accommodate the 5 scores. It would, for example, look as follows. So these are 5 scores or 5 values that are being stored in memory under one name. And this is what we are calling an array. If these values are to be stored in memory, that is 60, 40, 11, 18, and 95 in that order, then that will form an array. And therefore, these scores are indicated to be a single row because they are for a single student, as you have seen. However, if you want them to store the marks scored by several students, for example, 5 students in a single exam, then we would still have it as a single dimensional array. And we would, for example, store it in form of a column. That is 60, 40, 11, 18, and 95. And by this arrangement, I'm trying to indicate that each of these scores belongs to a single student. But remember, we are not including the name of students accompanying or being accompanied by their scores. So 60, 40, 11, 18, and 85 will be in a single column. This would mean that we have the scores entered in a single column, just as I've said, as an indicator for the single subject or exam, but with each score being in its own row as an indication that each score belongs to a different student. In addition, if you wanted to compute the total marks that several students, for example, 5 students have attained in several exams, for example, in 5 exams, then you would have to declare an array that would accommodate the 5 scores for each of the 5 students. And therefore, it would look as follows: 60, 40, 11, 80, 95. That would be for a single student. Then the next 40, 32, 90, 100, 12. That would be scores for the second student. Next, that would be the next student, the 40th student, and the 50th student. As you can see, these are 5 rows, and each row consists marks for a single student. And in this case, then, this would mean that first row are marks for the first student in 5 exams. Then for second student, second row. Third row for the third student, fourth row for the fourth student, and fifth row for the fifth student. However, I still remind you, my dear students and the rest of the learners, that we are not going to include the name of the student. In this case, each of the 5 columns would be indicative, just as I've said, of each of the 5 subjects, while each of the 5 rows would be indicative of each of the 5 students. Arrays are therefore identified in terms of their dimensions. These dimensions can be fixed or predetermined and cannot be changed during a program execution. In addition, the number of elements in an array is called its dimension, and these dimensions are identified using subscripts. Therefore, the two main categories or types of arrays are the one-dimensional array that we abbreviate as 1D and multidimensional arrays. Let's look at one-dimensional array. What is the one-dimensional array? This is an array with elements arranged in a single row or a single column, but with several columns or several rows. No, let me correct. That is a mistake that is usually made by many students. When we are speaking about one-dimensional array, this is arrangement of elements in a single row, but with several columns. Sometimes we don't even mention about the columns. We only talk about a single row. And as a result, that kind of an array can be said to be organized in row major order. The other alternative is to have those values arranged but in a single column. Now that would mean that in other words, you have several rows, but note is only a single score per row. And what does that mean? It simply means that these scores are in a single column. So in that case, we may not talk about several rows because one-dimensional array does not or is not supposed to be said to consist of rows and columns. However, sometimes when the elements are arranged, for example, in a single column, in a real sense, it simply means that each value or each element is occupying its own role. If they are arranged in a single row, it would still mean that those values, each value is in its own column. So because it's only a single value that is in a single column, then sometimes we only say that one-dimensional array has only either one row or one column, but not a combination of both. I know that's confusing, right? We are going to understand more when we are going to look at the multidimensional arrays or the two-dimensional arrays, three-dimensional arrays, etc. So an example of a one-dimensional array is where a single student takes 5 exams, thus scoring a single score in each, which can be written in a single row, what we call row, major, order. So when we are speaking about one-dimensional array, we are speaking about elements being stored in a single row. And why talk about row instead of talking about the column? It is simply because even the compiler stores the elements in form of rows, regardless of whether those elements are in the columns or not. So even if you have data or elements organized in columns in form of a table, when it comes to storing those elements in memory, those elements are stored as rows. So a one-dimensional array will look as this: 60, 40, 11, 18, 95. This is a single row. So this is said to be row major. In this case, each element represents a score attained in each one of the 5 exams by the student, thus having our elements or scores represented in a single row. But of course, just as I've said, if you have to look at each of the elements in using the eye of columns, then you would say that those elements are also in the columns, but a single element per column. So we ignore that. The following is therefore a one-dimensional array with the elements represented in one row. But of course, just as I've said, you can talk of 5 columns. I know that's still confusing, but that is the purpose of this presentation. Simply, when we are representing elements in memory, just as I've said, those elements are represented in the form of a row. So, one-dimensional array has elements arranged in a single row. That's what is important. Forget about the issue of the columns for one-dimensional array. Oh yes, note that. Therefore, know that it is only the data input that is entered and stored in the computer's memory. 60, 40, 11, 18, and 5. That's what is stored in memory. Or where we have 5 students sitting for a single exam, thus each attaining a single score. Then, because these are scores in a single exam, then we can of course have that data organized in a single column, what we call column major order. That way, as you can see, this is a single column. So that's a one-dimensional array. It's a single column. Forget about the issue of rows here. It's a single column, right? Yes, it's a single column. 60, 40, 11, 18, 95. The following is therefore a one-dimensional array with the elements represented, just as I have said, in 5 rows, but in one column. So what is important here is a single column, because this has scores in a single subject. And we are not interested with who scored what. We're interested with scores in one subject. And therefore, those scores are in one column. That is 60, 40, 11, 80, 95. But in the eyes of the viewer, you can, of course, see that each of these elements, if you have to look at them in terms of rows, they are occupying rows. But just as I've said, for one-dimensional array, you talk about data being organized in a single column or in a single row. Full stop. Note that it's only the data input, just as I've said previously, that is stored in the computer's memory. That is only the data that is of type integer here. If you were to store R1, R2, R3, R4, R5, then that would be also an array, but not of type integer. It will be of another type. So in arrays, you only store values for one data type. If it is integer, it is integer. If it is float, it is float. If it is char, it is char. If it's boolean, it's boolean. If it's long, it's long, just as we discussed in my previous presentations. In this case, each value represents a score, of course, attained by each of the 5 students, but in a single exam. So the emphasis here is in a single exam, and that's why I'm organizing these elements in a single column. But note, it is one-dimensional array. Why? The data is occupying a single column. If you have data occupying several columns, complete several columns, another column with another set of figures, 5 of them, then that would be a different dimensional array, as we are going to see. Now, what are dimensional or multidimensional arrays? Multidimensional arrays are arrays with more than one dimension and are sometimes called tables or matrices. What we have looked at, the one-dimensional array, sometimes people call it vector. But for multidimensional array, because this is data which is stored in form of rows and columns, several rows and several columns, then we call it a table or a matrix. Now, their elements are usually organized in several rows and several columns, and that's what differentiates between both dimensional arrays and one-dimensional array. Therefore, an array composed of 2 dimensions, that is rows and columns, is called a 2-dimensional array, while an array that is composed of 3 dimensions, that is, the data is stored in form of width, length, and depth, or in other words, data is stored in reference to 3 different views or aspects, then that's a 3-dimensional array. And we abbreviate it as 3D. The number of rows and the columns that an array has defines its order. So, an example of a 2-dimensional array, which is of order 5 by 5, is a case where we have 5 students, with each student having scores in 5 exams, represented as follows. So, if you look at this data, this is an array. This array is composed of data stored in 5 rows and 5 columns. Due to that aspect, that we have data in the rows and in the columns, that's a 2-dimensional array. But of which order? The order is determined by the number of rows or columns that the array has. If this array was to have only 4 rows, this would be 4 by 5, meaning 4 rows but 5 columns. If it was that way, that would be 3 by 5. A 2-dimensional array, but of order 3 by 5. We always begin with the rows, and therefore, this would mean that this data is in the order of 3 by 5, meaning it is occupying 3 rows but 5 columns. And it is still a 2-dimensional array. Why? The data is stored in rows and columns. But if you are to introduce another aspect, which is not rows and not columns, but something else, then that would be a 3-dimensional array. So in this case, as you have seen, each of the columns from column 1 to column 5 would represent first exam scores to the 5th exam scores, respectively. While each of the rows from row 1, that is R1, to row 5 would represent first student's scores to the 5th student's scores, respectively. In other words, what we are saying is, if this is our array, of course, this first row is scores for a single student, but these are 5 scores. So each column represents a score attained in 1 unit, for example. So 60 belongs to a certain unit, 40 to a certain unit to exam, 11, 18, and 5 the same. So these 5 elements are in the single row. So we can treat them to be for a single student. So these are scores attained by a single student in 5 exams. Then second student in 5 exams. Third student in 5 exams. Fourth student, but 5 exams. And fifth student in 5 exams. However, note, we are only going to store numbers. We are not interested with the names, whose these marks belong to, neither are we interested in the name of the subjects or exams. So we can represent this data in table format like this. This is purely for our identification purposes. Otherwise, if we are storing this data, we are only going to pick the numbers. But it's important for you to note, my dear students, and the rest of the learners, how we organize data when speaking about arrays. So this table is a two-dimensional array. The data is organized in columns. So we have column 1, column 2, column 3, column 4, and column 5. And in this case, I'm informing you that what is in one column can represent a scores in exam 1, column 2 scores in exam 2, column 3 scores in exam 3, then column 4 scores for exam 4, and the column 5 scores for exam 5. However, that is for the viewer, for the user. What the compiler is intended with are the numbers, but the order is important. What is in which column? What is in which row? Then we have row 1, row 2, row 3, row 4, and row 5. And in this case, whatever is in row 1, whatever is in row 2, whatever is in row 3, whatever is in row 4, and whatever is in row 5, those are scores for a single student. That is student 1, row 1, student 2, row 2, student 3, row 3, student 4, row 4, student 5, row 5. Now, in multidimensional array, like two-dimensional array, what is of our interest is what is in which row and what is in which column. Which element is in which row, which element is in which column. That's what is of our interest. Therefore, just as I have said, it is only the data. Now, in this case, let me not say it's only the data in broad that is entered and stored in the computer's memory, because what is in broad here is student 1, 2, and 3. So what we are going to store in memory is not what is in broad in this case. So that's a mistake. So let me cancel this statement. I'm saying, know that it is only the data in broad that is entered and stored. Now, in this case, what is in broad are these names. So if we were to store only these names, this would be an array, but a different array. It will not be an array of integers. Our interest is these elements here. So how is this statement supposed to read? It's only supposed to read that it's only the values. It is only the numbers. It's only the numbers that is going to be stored in the computer's memory. Let's avoid this mistake that many make. So we cancel these parts. And then the statement is to read, note, it is only the values. It's only the values entered in this table that are going to be stored in memory. So this data, just as I've said, can be stored or can be said to be stored in two-dimensional array, but in 5 rows and 5 columns. In 5 rows and 5 columns. As you can see, I've already identified what is in the row, what is in the column. But note, each element is occupying a row and a column at the same time. Because like if you are to pick 60, this is the intersection between column 1, row 1. So we did it as row 1, column 1. If I was to pick a figure like 30, this would be row 3, column 4. If I was to pick an element like this one, that would be in the row 5, column 2. Very important. My dear students and the rest of the learners, I'm taking time to explain this because once you understand how data is organized how you identify an array, how you identify the dimensions. That is what is important, because that is the knowledge that is needed for you to be able to write the programs for manipulating elements that are stored in memory as an array. How do you refer to elements of an array? Whenever you want to refer to the elements of an array, you can do it in either of the following two ways. Number one, in terms of rows and the columns, or number two, in terms of the index, or what we call the subscript. Now, how do you refer to array elements in terms of rows and the columns? Due to the fact that in arrays, elements are normally stored in row order, it is always advisable that whenever you are referring to an element from the array, you always begin with the row first, followed by the column, regardless of whether you are making use of row order or column order, row major or column major. That's why even for multidimensional arrays, the compiler usually maps the array elements to a single dimensional memory in row order, such that when one row has completed being stored in memory, the next row is stored. Therefore, this is how we would refer to our elements in the one-dimensional array that we have already discussed. So if you are to refer to 60, 40, 11, 18, and 95, we would simply say, in terms of row and the column, even though I have said that for one-dimensional array, our interest is not usually in which row or in which column our value are, but we are only interested with which row is occupied by our values, which column. But for the purposes of knowing how we can identify elements that are in a one-dimensional array in terms of their rows and the columns, then this is what we do. And this is purely for learning purposes. Otherwise, when it comes to storing in the computer is interested, or the program is interested with identifying these elements in terms of their index. And that is the best to avoid the ambiguity of a student confusing between a single dimensional array and a multidimensional array. With the index, it becomes easy because the index does not really talk about, for one dimension, it does not really care about the row or the column. It's interested with the possession, as we are going to see. Now, for learning purposes, how do we identify our values using the row and the column format? So the elements in the above table would be read in row major as follows. It would be read as row 1, column 1. That is 60. Row 1, column 2. Row 1, column 3. Row 1, column 4. Row 1, column 5. And that can be written as follows. 1, 1, meaning row 1, column 1. 1, 2, meaning row 1, column 2. Always the second digit is for the column. The first digit is for the row. Always. 1, 3, 1, 4, 1, 5. So if someone was to look at this arrangement, a person would directly tell that this array is a one-dimensional array because the elements are organized in a single row. And therefore, in this case, first element, second element, third element, fourth element, fifth element, all of them are beginning with 1, indicating that those elements are occupying a role, even though the columns are changing. Now, if we had organized these elements in form of a single column, then we would identify them as row 1, column 1. Now, note this. We would still read it as row 1, column 1, row 2, column 1, row 3, column 1, row 4, column 1, row 5, column 1. What is changing here? What is changing here is now the rule. For the other example, the one which I've given, in this case, what is changing in row major is that you read the row completely, first, all the elements in that row. So in this case, what we're changing are the columns, but the row remains as 1 or remained as 1. But in this case, where the 5 elements are organized in a column, then each of the elements is occupying its own role. And therefore, we identify it as row 1, column 1, row 2, column 1, row 3, column 1, row 4, column 1, row 5, column 1. And when we are writing, as you can see at the bottom here, you can see we have 1, 1, meaning row 1, column 1, then 2, 1. That is row 2, column 1. 3, 1, meaning row 3, column 1. And the same applies to 4, 1 and 5, 1. What is not changing here is the column. So where we read all the elements in one column and we complete. Before moving to the next column, if it has more than one column, then we call that column major order. So in this case, 1, 1 refers to 60. 2, 1 refers to 40. Row 3, column 1, 11. Row 4, column 1, 18. Row 5, column 1, 95. So 5, 1 refers to 95. As you can see here, 5, 1. Row 5, column 1. Kindly note, my dear students and the rest of the learners, whether you are referring to elements using a column major order or using a row major order, always remember the dimension or the sign or the value that begins first is the role, as you have seen. So for column major, what is changing is the role, and we are beginning reading the role followed by the column. For this row major, we still begin with the role. The only difference is within the entire row first and we complete. For the column major, we read every element in column, but we complete the column first. So we can use like 3, 1 to refer to an element. So when we talk about 3, 1 in a certain array, you can easily tell what we are referring to. So as you can see here in the column major for one-dimensional array, the column is remaining constant while the role is changing, and that applies to all dimensions. However, this is how we would refer to our elements in a multidimensional array, such as 2D that we have already discussed. So if this is our array, and you can see our elements are there, 60, 40, 11, 18, 95, 40, that 290, 112, 11, 50, 23, 30, 98, 18, 78, 18, 02, 11, 95, 71, 45, 19, and 61. You can see that we still refer to each of the elements using row column. So if you are to read these elements in row major, how would we read them? What about in column major? Let's see. In row major, all the elements in one row are first read. Then you proceed to the elements of the second row and you continue up the last row's last element, just as I've said. And therefore, the elements for above array would read as follows. It would read row 1, column 1, row 1, column 2, row 1, column 3, row 1, column 4, row 1, column 5. That is R1, C1, R1, C2, R1, C3, R1, C4, R1, C5, R2, C1, R2, C2, R2, C3, R2, C4, R2, C5, R3, C1, R3, C2, R3, C3, R3, C4, R3, C5, R4, C1, R4, C2, R4, C3, R4, C4, R4, C5, R5, C1, R5, C2, R5, C3, R5, C4, R5, C5. That is how we read the row major order, the elements in row major order. You can see the last is row 5, C5. And the first one is row 1, C1, which I've already said. So the elements can also be defined as follows. Now, what we only remove is R and C. So we retain the figures only, like 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. Then we have 2, 1, 2, 2, 2, 3, 2, 4, 2, 5. 3, 1, 3, 2, 3, 3, 3, 4, 3, 5. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5. 51, 52, 53, 54, and 55. So we only do away with the R, the letter R, and the letter C. So in this case, each of these are referring to a certain value. Like row 1, column 1. What do we have there? Let's see. Row 1, column 1 is 60. What about row 5, column 5? Row 5, column 5. This is row 5 and column 5. So the intersection where the two are meeting, that is the value there. So row 5, C5, we are referring to 61. What about if we wanted to refer to this value here, 90? How would we refer to it? That would be row 2, column 3, row 2, column 3. And that's how we go about reading of the elements. So when we talk about 1, 1, we are referring to 60, 1, 2, 40, and etc. And the list continues. What is important is for you to be able to know that when we are talking about row 2, or when you have a figure like 2, 4, that is row 2, column 4. What is at the intersection between row 2 and the column 4? It is 100. What is in the intersection between row 2 and the column 5? It is 12. What is in the intersection between row 4, column 3? It is 18. That's what is important, how to identify them. So, and the last one, in row 5, column 5, what we have is 61. Therefore, the elements in the two-dimensional array will just be read as follows in row, major, order. We read in row, major, order, all of them continuously, one look the next. What only informs you that we have changed the row is the number of elements, the order. So if you know that the order is 5 by 5, so when you complete the first 5 elements, when you complete reading the first 5 elements, you know the row are changed. Like this one then would mean that all the elements here, it is in row 1, R1, but the column is changing. So in row major, and this is how even the data is stored in memory, the elements are read as if they are continuous, but you only differentiate, or even the compiler only differentiates where one row has been completed based on the order of the array. So if, like in our case, our order is 5, and therefore that's 5 by 5. So it means we read 5 elements. Then when you're moving to a 6th element, we know the row are changed, like 60, 40, 11, 18, 95. 40, 32, 90, 100, 12. 11, 50, 23, 30, 98. 18, 78, 18, 02, 11. 95, 71, 45, 19, 61. So once you know the order, you can tell. Like if it's 5 by 5, we did 60, 40, 11, 18, 95. 40, 32, 90, 100, 12. 11, 50, 23, 30, 98. 18, 78, 18, 02, 11. 95, 71, 45, 19, 61. So we can easily tell that if we were now to count, this would be row 1, row 2, row 3, up to here, row 4, row 5. So we can easily tell, if I also pick this element here, I then count, I know this is row 5. So what about the column? It is 1, 2, 3, 4, 5, because each of the elements is in its own column. And therefore, that will be row 5, column 5. It is row 5 based on the order. And it is the last one in that column. So, my dear students and the rest of the learners, that's how we identify our elements, even for multidimensional array. And that's how the elements are stored. Now, in the column major order, it's just that we begin with the column. So all the elements in one column are first read. I repeat, I know I've said we begin with the column. Note, you begin reading all the elements in one column. Then you move to the next column, then the column, etc. But for each specific element, you begin reading the row. So all the elements in one column are first read. Then you proceed to the elements of the second column and you continue up the last column's last element. So therefore, the elements of the above array would be read in the column range as follows. Row 1, column 1, row 2, column 1. Note, I'm currently reading the elements for column 1. So in this case, I have row 1, column 1, row 2, column 1, row 3, column 1, row 4, column 1, row 5, column 1. Then that column finishes. Then you move to the next column. Row 1, column 2, row 2, column 2, row 3, column 2, row 4, column 2, row 5, column 2, and we finish that. Then we change the column. We move the next column. We begin row 1, column 3, row 2, column 3, row 3, column 3, row 4, column 3, row 5, column 3. We finish column 3. Remember, what helps you to know that we are changing the column is the order. This array is 5 by 5. 5 rows, 5 columns. So whenever you read 5 subsequent elements, you know you have changed the row and you have also changed the column. But because we are reading the column major, once you read 5 elements, you know that the column are changed. Row 1, column 4, column 4, column 4, column 4. When you reach row 5, you know that column is done. Then row 1, column 5, column 5. You can see. So what is important is that regardless of the type of array that you're working with, always, if you are reading the elements in column major order, you complete the elements of one column first, but beginning with the row. Good. I believe you are getting it right. So these elements can also be referred to as follows, just as it was for the one dimension. So we can refer to them in column major. As you can see, whatever that they're changing, if you see, for example, what they're changing is the column, like in this case, or is the row, like in this case, what they're changing between this one and this one, what they are changed is the first element. So what they're changing is the row. The same applies here. What they're changing is the row. But this other second element is not changing until the order are changed. So that is what helps you identify the order which is being used. Is it row major or column major? If you find that what is changing is the row, then that is column major. If you find what is changing is column, for every element the column is changing, that will be row major. I repeat, if you find that what is changing per element is the row, like 1, 1, 2, 1, 3, 1, because you have seen the first element, the first value always indicates the row, then that would mean that the values are being read using column major, because the column is not changing until you complete the entire 5 elements in this case. So it is the same as the row major. The way we have referred to them, the only thing that you need to note is that what is changing in the column major is the row for each of the aspects. What is changing is the row. So in the column major, the row changes per element. You read the element per row, but retaining the column. Once you're through with, for example, in this case, because it's 5 by 5, once you are through with 5 elements, then you change the column. So very important to remember, my dear students and the rest of the learners, so that you can be able to handle arrays effectively. This is the foundation knowledge that is very important for you to be able to write the programs in C++, and not only in C++, but also in other programs or other programming languages. So in this case, when I talk about 1, 1, if, for example, I'm reading using column major, like in this case, you can see between the first line and the second, what are changed the first value for each. So 1, 1 refers to 60. 2, 1 refers to 40. What simply this means is we are reading in terms of column major. But the most important thing to remember is that always the first digit is the row. The second one is the column. So row 1, column 1, 1, 1. The value there is 60. What about row 2, column 1? The value there is 40. Let's see. Let's see. This is our array. I want to go back all the way to the array. If, for example, I talk about row 1, column 1, that will be 60. Row 2, column 1, that will be 40. Row 2 or row 3, column 1, that is 11. I'm reading using column major because I'm reading the elements in one column first. If, for example, I was to read this element here using column major, how would I read it? That would be row 3, column 4. But because it's column major, I must complete all the elements in that column. So the next element must be within this column. And therefore, next will be 4, 4. Then this is 4. That is 5, 4. 5 for row, 4 for column. What about this one? That would be 1, 5. Then this would be 2, 5. Then this would be 5, 5. Note, when you are using column major, you complete all the elements first for that column before you change the column to another one. Very important, my dear students. Now let's proceed. So that's how we distinguish between row major and column major when it comes to reading the values or the elements. Therefore, the elements in the above two-dimensional array will just be read in column major order as follows. In other words, you just list the elements once you have known how to read them. So you read, remember I've said, you read all the elements in one column first. So if, for example, once I know that I'm reading my elements in a column major, and this multidimensional array, this 2D array, is a 5 by 5. I only need to count 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That is 5 elements, as you can see, 5 elements. That is 5 rows, 5 columns. So if I was to talk about by looking, it was to identify 78 in this case. Where do I expect this value to be? This value will be in, let's see, column major. You read row, column. So row 1, column 1. Row 2, column 1. Row 3, column 1. Row 4, column 1. Row 5, column 1. Then we change column. So this is column 1. This is column 2. This is column 3. This is column 4. This is column 5. And therefore, this 78 would mean that is 40, 1, 2, 3, 4. So that would be 4, 2. 4, 2. This is 1. This is 1, 2. 2, 2. 3, 2. 4, 2. 5, 2. So this would be 1, 2, 3, 4. So this is 4, 2. Let's go to our array and see whether that is true in the column major. Let's see what is in 4, 2. Here we are. Where is 4, 2? 4, 2, 4. Row 4. row 4, row 4, 2, row 4, column 2, row 4, column 2. You can see it's 78. Row 4, column 2. There we go. Row 4, column 2. That's 78. Very important. So, having known how we identify our elements using row major, column major, using R1 or using letters R and C, and also having known how we use the subscripts, then if we are to read those elements directly using column major, we'll just read them as 60, 40, 11, 18, 95, 40, 32, 50, 78, 71, 11, 90, 23, 18, 45, just continuously in that order. And of course, when it comes to storing them in memory, that is how they are going to be stored. Continuously. The second way of identifying elements and referring to them is using index or subscript. And this is what now the programming languages use. Once you have known how you can identify the rows and the columns, major, order, and the column, that is row major and the column major, then that knowledge now helps you to be able to know how the compiler is able to identify those elements through subscripts, because the same applies. So when you declare an array, you instruct C++ to reserve a specific number of memory locations for that array. Therefore, an array variable is defined by specifying its dimension and the type of its elements. The number of dimensions are identified by the number of subscripts used during the declaration. These subscripts are placed in square brackets after an array name for each dimension. Therefore, the compiler identifies the type of an array based on how it's declared and defined by the programmer. Therefore, you will reserve the memory to be used by an array by informing the C++ compiler concerning the number of dimensions that it has. For example, a one-dimensional array has a single subscript, while a two-dimensional array has two subscripts. A three-dimensional array has three subscripts. So at declaration, if you see the number of subscripts that have been written there, that will help you to know how many dimensions that array has. Each subscript within a square bracket indicates the number of elements that each dimension has. The syntax for declaring an array is usually as follows. For a one-dimensional array, it has a single subscript and decoded as follows. Data type, array name, and size. Why I have only a single subscript is just because I said data in one-dimensional array, we talk of values being in one row or one column. Just that. And as a result, the subscript that we have just tells us it's one dimension. Whether it is one row or one column, that's not the issue. But it is only one subscript. So we enclose a subscript in square brackets. For example, the array declarations for the data in the following tables that we have already discussed would be declared as int student discourse. Student discourse is the name of our array. Like in this case, we can see this is, we have student, and the data here is for student, but it's course in 5 subjects. So the best name would be student discourse. You can remove the character here, the underscore. You can remove it and then have it as a single word. But these are good practice methods of writing variable names. So in this case, the data in this table is whole numbers, no fraction. So that is an integer. So data type is int. Then the array is called student discourse. But how many values are there? 5. And that's what we enclose in square brackets as 5. Now, if it is in column, the way we have it, you can still see that it doesn't matter whether for one dimension the elements are in a row or in a column, as long as it's one row or one column. And that's why we're using only a single subscript. You can see, if you look at int, the declaration here, int student scores 5, you cannot tell by looking at the declaration whether the 5 elements are in one row or in one column, as you can see. So the number of elements are 5. And they're of what type? Integer, int. And the variable name is students scores. As you can see, for a one-dimensional array, we don't mind with whether the elements are in row or a column, because at the end of the day, the compiler reserves contiguous memory for arrays in the form of rows. In addition, for a one-dimensional array, what is usually important is the number of elements that the array has, and not whether those elements are in form of a row or in a column. After all the elements are in only a single row or a single column. For a two-dimensional array, it has 2 subscripts or indices, one for the row and the other for the column, with each subscript indicating the number of elements per each of the 2 dimensions, or according to the order. And the syntax is data type, array name, and you can see now we have size of row and size of column. The names can change. These are just for my use. You can tend to replace size of row with something else, like length and width, or term exam cut, or term 1 score, term 2 score. It can be anything, but there are 2 dimensions. And for each, there is size of that dimension, size of the row or size of the column in our case. For example, the following would be the declaration for a 2-dimensional array to store the elements from the table below. So if this is our table, you have the data with you. How do you know how you declare? 1, look at the data that is going to be stored. Like in this case, our data is this one here. So what type of data is this? This is type integer, and that is int. But what are we storing? It is students' scores. So our array name is students' scores. Now, if you look at this data, it is organized in rows and columns. So you count them. How many rows do you have? So we have row 1. Sorry, I've not drawn it nicely. Let me repeat. We have row 1. We have row 2. We have row 3. We have row 4. And we have row 5. That's okay. But of our interest is, now that's one dimension, first dimension, okay? But how many elements are in each of those rows? How many elements per row? The number of elements is 1, 2, 3, 4, 5. And they are the same, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we put that in the first subscript, 5 elements. So we can tell that because it's a 2-dimensional array, for the first dimension, each row contains 5 elements. Then the second subscript, this one, is for the next dimension, and in this case, the columns. So how many columns do we have? We have column 1, column 2, column 3, column 4, column 5. But of our interest is how many elements are in each column. So you count them. A column, like if I was to pick first the column, you can see it has 1, 2, 3, 4, 5. This time we are counting column-wise. Remember, for the first subscript, we are counting per row. So in this case, we are counting per column. Let's count column 2. It is 1, 2, 3, 4, 5. So enclose 5 in square brackets for the second dimension. So that's how we come up with the declaration. That's how you declare your variable if it's 2-dimensional or 3 dimensions or more. This means that this is a 2-dimensional array, as I've said, composed of 5 rows, with each row, in this case being 4 values for a single student, and 5 columns, with each, of course, being for the score in a single or a specific exam, as you can see. But what is more important is how many elements are in each row and how many elements are in each column. In other words, how many elements are in each dimension. So it can be said to be a 5 by 5. If, for example, one row, like row 5 was missing, then this would be, it would mean that if row 5 is missing, then it means the number of elements per row will be 5, but per column, there will be 4. So it will be 5, 4. So the order will be 5 by 4. So a 3-dimensional array's declaration is composed of 3 subscripts. And the syntax is data type, array name, size of dimension 1, size of dimension 2, size of dimension 3. For example, if you wanted to declare an array for storing scores attained by 5 subjects in 5 exams for 3 terms, note, 5 students in 5 exams for 3 terms. So students, exams, and terms. Already, that's a 3-dimensional array. Those are 3 dimensions. First dimension is how many students? 5. How many exams? Second dimension, 5. How many terms? One dimension, 3. So its declaration would be, just as I've said, data type, array name, number of students by number of exams by number of terms. So it would be, if you are to be asked which order is this, it would be 5 by 5 by 3. That's the order. 5 by 5 by 3, meaning what? There are 5 elements in the first dimension, there are 5 elements in the second dimension, and there are 3 elements in that dimension. What type of data is in each of those dimensions? Whole numbers, integer. But what are we storing in the array? What is the name of our memory that is being set aside to accommodate our elements? Students' scores. So a similar process will be followed to manipulate other dimensions, like 4 dimensions, etc. Then once an array has been declared, the individual elements of the array are accessed and manipulated or referred to by indexing the array's elements. You have the dimensions, yes, but how do you identify each of the elements? Therefore, each specific element in the array is identified using an index. The index is also called a subscript, and it is used to differentiate array elements. It is usually a number in square brackets after the name of the array. The index for identifying array elements commences with index 0. So if you are talking about the first row, elements in the first row, the first element in that row will be 0. Second element's index is 1, etc. The same for column. First element in that column 1, for example, will be 0. Column, the second element in that column will be 1. The third element in the same column will be 2, etc., as we are going to see. Now, this means that for you to get the index for an element, you subtract 1 from the element's positional value in the array. What does that mean? If, for example, you have 5 elements, or your array is, each row has 5 elements, it simply means that the index runs from 0 to 4. Because if you count 0, 1, 2, 3, 4, those are 5 elements. And therefore, if your row has 5 elements, it simply means that the index for the first value, of course, will be 1. That means position 1 minus 1. That would be index 0. Or the index for the second element in the array would be 2. That is position 2. Number 2. But which index? 2 minus 1. Because the first element is always index 0. That will give you 1. And this continues up to the last index. So the index for the last element will be the number of elements minus 1. Therefore, in order to identify the index for an element in an array, we subtract 1 from the element's position in that array. So if you asked, which element is position 2? Which element is in position 2? Or which index? Which index is for the element in position 2? It is just 2 minus 1, and it will give you 1. Therefore, in order to identify the index for an element in a certain position, you always subtract 1 from that position. For example, the index for the 6th element in an array would be 6 minus 1, giving index 5. Well, to know the position of an element in an array, if you are given the index of that element, just add 1, and it will give you the position. So, if an element is index 5, then it means that we are referring to the element at the 6th position in the array, which is gotten by adding 1 to 5. That's what we are saying. Therefore, the first element in an array is always indexed as 0, or the last element will always be that position's element minus 1. If it is number 9, position 9, it will be 9 by minus 1. That means the index will be 8. So the main difference between the subscripts for an array declaration and an index for a specific element is that the subscript in a declaration indicates the number of elements per each dimension, but the index for a specific array element indicates its order in the array. So if in the declaration we have 5 for first subscript, then it means that the first element there will be 0, but the last one will be 5 minus 1. That will be 4. For example, if you have the following two statements in C++, a declaration for an array called score, which is going to hold values of type integer, and those values are 5. And then you have another statement which reads score 5. Because this is not a declaration like int, we are not being told the data type there. Then what we are simply saying is that because it's not a declaration, we are referring to an element in an array called score. And that element is the element with index 5. That simply means that this element we are referring to as score 5 will be the 6th element in the array. So the subscript 5 in the statement int score 5 would mean that the array score has a maximum of 5 elements in it. However, the subscript or index for the second one, 5 in the statement score 5, means that we are referring to the element in the array whose index is 5, meaning it is the element at the 60th position in the array. Good. We can therefore refer to our elements in the following arrays using index instead of using columns and rows as we have done before. So if you have a one-dimensional array that has been declared as follows, like that, the array is called student scores. It has 5 elements. Those elements are of type integer. Then, if you have another one, which, for example, the array is called students scores, it has elements 5. The two are the same. The only difference is the name. So the data in this kind of an array would simply be as follows. It is student scores, these are our values. 60, 40, 11, 18, 95. 60 is the first one, is the first position, while 95 is the 50th position. So you can already tell which index is 95, which index is 60. Now, for the two-dimensional, or for the same values, but in a column, it will be like this. And you can still see 60 will be first index, 95 will be the last index, regardless of whether data is in the form of a column or a row. As long as it is one, dimension. So we can refer or access each of the elements in the above array using index as follows. 60 is element number 1. So its index, note, the element's index is identified using two things: the name of the array in which that element belongs and its index in that array. So 60 will be student scores 0, index 0. 40 is in position 2, so it is student scores 1. And the same continues to the last one, which is 95. It is in position number 5, and therefore its index is 4. So its elements index is student scores 4. It has the fourth index, meaning it's the fifth element. Therefore, the array elements for one-dimensional arrays that we have already discussed can thus be represented using index instead of rows and columns. So our array will be declared as that, or using this other second declaration here. That is for the first and for second, but both of them are one dimension. So if these are our elements, regardless whether in the row or a column, 60, 40, 11, 18, 85, their index will be, as you can see. The first, if it's a one-dimensional array, the first element will be 0, and the last one will be 4. We have said a situation where elements are identified using only a single subscript. That is a one-dimensional array. For a two-dimensional array that we have already seen, we can declare it as int student scores 5 by 5. And note, even though I'm saying 5 by 5, we are talking about two dimensions for column and for row. And the table is like that. So that's how you declare it using the subscript. Simply, it means the array is called the student's scores. The data that we are storing is of an integer, the numbers. But how many values per each dimension? So per column, we have 5 elements. So that is for row. Per row, we have 5 elements. Per column, we have 5 elements. That's 5 by 5. Now, we can therefore refer to each of those elements in that table using row order, as compared to refer to them using index as follows. First element is in row 1, column 1. So what is its index? Remember, for a two-dimensional array and more, you identify an element using two subscripts. One that indicates the row, and the other one for the column. So if an element is column 1, it is position 1 in the column. Its index will be 1 minus 1. That will be 0. If it is the first in the first column, or if it is in the first column, then it will be 0, 0 is the first element in the first column. And we continue like that. If you are referring to the element like 11, which is in column 1 at row 3, you just subtract 1 from each of those numbers to identify the index. So 1 minus 1 is 0. 3 minus 1 is 2. Let's go to the last one. Let's go to the last one and see. You can see, if for example, we are to pick the one which is in column 5, that is row 5, column 1. Its subscript or its index would be 5 minus 1 for first dimension. That gives 4. 1 minus 1, that gives 0. So it will be student's scores 4, 0. So if you are given an index of an element with its name, you can easily tell which position it is. Like if you are given student's scores 4, 0, note the difference. The subscript is enclosed in square brackets. But when you're identifying in terms of just the rows and the columns, it is just the normal parentheses. If you compare, if you look at the way I'm writing this and the way I'm writing this, it is different. For elements index, you can see I'm using square brackets. where I'm just simply referring to the row and the column in which the value belongs, I'm just using a pair of parentheses. And then what is inside is the possession. Row 5, column 1. If I was to go, for example, to my last element here, you can see 61 is in row 5, column 5. That is row column. But for index, it is 5 minus 1, giving 4, and 5. And 5 minus 1, giving 4. Very important. Kindly, my dear students and the rest of the learners, note that difference and how we identify each of them. So just as you have seen from the table, you should never leave the name of the array. Anytime you want to refer to an array element, nor leave out the full subscript. Therefore, the array elements for the two-dimensional array that we have already discussed can therefore be represented as follows, using the index instead of rows and the columns. So that's our array declaration. Our index is that, and our values are there. First row, second row, third row, fourth row, fifth row. You can see, like to identify element number 30, if we were to identify this element here, it would be 2, index 2, that is 2, 3. So we will write it as we enclose 2, meaning index 2 and index 3. But we must include the name. So we have to include the name, student scores there. So student scores 2, 3, meaning it is the element in the array at the intersection between index 2 and index 3. That means index 2 for the row, index 3 for the column. And that will help you to be able to know what specific element you are referring to from the array. The same applies to 3D and other dimensional arrays, because we access or manipulate the elements in those arrays using their specific indices for each dimension, just as we have done for the two-dimensional arrays. For example, if you have declared a 3D array as follows, in the student scores 5, 5, 3, then it means that the first element in this array will be accessed using index as follows. The first one, of course, will be position 1 for first dimension, position 1 for second dimension, position 1 for third dimension. So subtract 1 from each. 1 minus 1 is 0. 1 minus 1 is 0. 1 minus 1 is 0. So the first element in a three-dimensional array will have its subscript as 0, 0, 0. What about the last one? The last one will simply be the subscript that you have for each dimension minus 1. 5 minus 1, it will give you 4. 5 minus 1, it will give you 4. 3 minus 1, it will give you 2. And therefore, that will tell you the index for the first subscript, for the first element in a three-dimensional array, and for the last one. Now, how do you manipulate the elements of an array? How do you make use of those elements once you have known how to identify them using index? Once you have declared an array and have known how to refer to each of the elements in an array, you can therefore be able to perform each and every operation using an array, just as you do with other variables and data types. So the first step after declaring an array is to assign elements into that array. This is called array initialization and can be done in any of the following two ways. You can initialize elements at the declaration time, or you can initialize the elements in the program. So how do we initialize elements at the declaration time? And then how do we perform operations with them? Now, what we mean by initializing elements at declaration time is simply assigning values to an array within the code. When you are declaring, instead of prompting the user to enter them during program execution. To assign the values to an array, you enclose those values in braces, and then you separate them using commas. Therefore, the syntax for initializing the array elements at declaration time for one-dimensional array would be done as follows. The syntax is data type, array name. You don't need to specify any value within the square brackets. Why? Because you are going to assign the complete number of elements that that array is supposed to accommodate. And therefore, the subscript will be known by default by the compiler. Or the second way is to declare or to have data type followed by array name, and then you can enclose the number of elements within the square bracket. There's no problem. And then you assign values. When we use the second statement, we normally use this statement if the number of elements you are going to assign to it at declaration will not be enough, so that adequate space is reserved. But if you are going to have all the elements for your array already entered at declaration, then you don't need to include anything in the square brackets. But if you are going to only assign a few elements at declaration time into the array and leave others blank, then it's good that you put or you tell the compiler the size of the array that you have so that it can know you have given me 3, but this is a 5, it's supposed to have 5 elements. So it is going to be waiting for the other 2. If you don't give them, it will assign each of them as 0. So for example, to assign the following values to our one-dimensional array called student discourse, whose elements we have already seen, we just do it as follows. Already we have known how to declare. So what we only need is to assign equal sign. Then note, we have what we are calling braces. So this is a brace and this is a brace. You must always enclose your elements within the brace. That's what will help the array also, for the compiler know how many dimensions that you have, or how many rows and the columns that you have. I repeat, the braces will help you, or other compiler know how many number of elements will be, for example, in each row. So for one-dimensional array, we always have only a single row, and therefore you assign them like that, as you can see. Remember to terminate your statement as usual in C++ with a semicolon. The same applies. What is changing between my first declaration and the initialization and the second one is just the name of the array. But I can see this name is the same. Otherwise, even if it ran student discourse at the bottom here, that would be the same as long as the dimensions are the same. Now, if you look at these two statements, this first one and second one, they are the same. The only difference is that for the first one, we have not told the compiler how many number of elements we are supposed to put there within the subscripts, but we have told it indirectly by assigning to 85 elements. So by default, when the compiler executes this statement, it will know that by default, this array has 5 elements. But for the second one, we are telling the compiler the size of our array. We are still assigning to it equal number of elements. So in this case, our subscript that we have indicated there is not really that important because already we have assigned all the 5 elements. Otherwise, if you only assign 60 and 40, then it will be okay, because the purpose of the subscript is to inform the compiler the size of the array. How many number of elements are you going to store in it? It is important to note that if you are going to assign all the elements into the array during declaration time, just as I have said, you do not need to indicate the subscript or array dimension because it's implicit from the initializer. Therefore, if, for example, you have an array called student discourse with the 5 elements and you initialize all of them, then the best statement would be, just as I've said, like that. Leave the subscript out or leave the size out. However, there's supposed to be however, if you have an array that you want to assign the values partially and then assign the rest later, just as I've said, you must indicate the dimensions over the memory can be reserved for the remaining elements. For example, the array for student discourse that we have talked about, you can have it like that. It means the compiler will set assigned memory location adequate to hold 5 values, but we're only assigning 3. So what the value will the others get? The others will be assigned 0, waiting for any other value to be stored to it. So in such a case, the compiler will reserve memory for the remaining 2 elements by initializing the remaining 2 elements with 0. You can then assign the remaining 2 elements either by prompting the user to enter the values, or you can assign them directly to index 3 and index 4, like that. Student discourse index 3. That means the 4th element. You are assigning 18 to it. So this statement simply means that assign value 18 to the memory reserved called student discourse at position 4, that is index 3. The same for this statement. It simply says assign 95 into the memory location called student discourse, or the array called student discourse at index number 4. That means at position 5. So you can see, you can assign normally the way you assign to other variables. The only thing you need to remember is how you do it for the array. Always have the name of the array and its index clearly shown. However, in order to initialize the elements for a multidimensional array, each dimension is indicated using its pair of braces, while the complete array initialization is also enclosed in a pair of braces to indicate that all the elements belong to the same array. Therefore, the syntax for initializing a multidimensional array is as follows. For 2D, is data type followed by array name, then specify the array size for first dimension and for second dimension, and then next is have equal sign, then opening brace, then these your elements while separating each of the pair of braces with a comma. And then note that you must always have, if it's a 2-dimensional or more dimensional array, always enclose your dimensions within the opening brace and the last brace with a semicolon. So you can see each of these is enclosed in a pair of braces, but at the end of the day, the entire array's dimensions are enclosed between this brace and the last one. That is for multidimensional arrays. For that dimensional array, it's just the same, but then now we load more braces, as you can see, and also the number of dimensions are 3. So you list each of them, each of the specific elements per row, and remember, enclose each pair in braces, or each column, each row in its own pair of braces. For example, to initialize our 2-dimensional array called student discourse with the values in the following table, we do it as follows. So these are our elements and their index. So how would we initialize our array with all these elements? These are 5 rows and 5 columns. With our index being clear and the number of elements per row and per column being clear, then this is of course one declaration. The array is called student discourse. The values to be stored in it are of type integer, and it has 2 dimensions, 5 elements for first dimension and 5 elements for second dimension. So we have our brace there, the first one, and then we enclose each of the rows in bracket like that. You can see the number of columns per each will just be counted by default. Like if I was to pick, if the compiler was to read this one, it would tell that 60 is in first column, 4th second column, 11 second column, 18, I repeat, 60 is in first column, 4th in first column, second column, 11 third column, 18 fourth column, a 95, 50 column, but all of them in the same row. But you can see each of the rows is enclosed in a pair of braces. And lastly, because the entire number of rows and the columns are for one array called students course, we enclose that with that brace and with a semicolon. If you wanted to assign a value directly to a position in the array, for example, to assign 100 into the two-dimensional array, you just need to include its index. Like in this case, it simply means that store the value 100 in the memory location or in the array called student is course at index 1, 3. That simply means for first dimension, it is number 1. It not number 1, but it is index 1. Index 1. And for second dimension, it's index 3. So meaning this element is at what position within the array? It is in 1 plus 1. So 1 plus 1. It means it is in the row 2, 3 plus 1, 4. So row 2, column 4 in the array. If you would like to initialize the entire multidimensional array with a single value, for example, 0 at declaration time, you just do it as follows. Once you enclose 0 in pair of braces and you are assigning it to a one-dimensional array or two-dimensional array, it simply means that you are initializing all the elements 0. So if it is a 5 by 5 two-dimensional array, 5 by 5 two-dimensional array, it simply means that all the elements inside there, 25 of them will be zeros. In addition, if you want to initialize some of the elements with their specific values, and then have the rest initialized automatically with the value 0, you just need to do it as follows for our array called students course. So you can see in this case, I repeat, if you want to initialize some of the elements with the specific values, then you can initialize it like this. What does this mean? This simply means that these values are only for a single row. So this statement assigns values to only the first row's elements, and therefore the rest of the rows are initialized to value 0, or the rest of the remainder of the other elements are assigned value 0 by the compiler. It is also good to note that it is a good practice to omit the first dimension subscript for your multidimensional array if you are going to initialize all the elements of the array, because it will be automatically derived from the initializer. For example, if you are going to initialize our array with all its elements like that, so the first dimension will be automatic. That will be 5 rows. It will count them, because each row is enclosed in its own pair of braces, as you can see. So it will be filled automatically. But for the second dimension, you must always specify the number of elements so that it is able to know the boundary in memory. Once you have been able to assign values to an array, you can then perform any operation using those individual elements, just as you do for any other variable, such as adding values, comparing values, etc. If, for example, you wanted to compute sum for our one-dimensional array that we have just initialized, you could do it as follows. So if this is our array that we have already initialized and we wanted to compute the total, how would we do it? One, of course, you need to declare memory, that is, we are calling sum, which will hold the total. Then each of the elements, or and each of the elements, and assign the result to sum as follows. The first element is student scores 0 plus student scores 1 plus. The only difference between this expression, my dear students, and the rest of the learners, or this statement, is purely the issue of including the array name and the subscript. So you can even add 2 elements only, like when deciding to add the student scores 0 and the student scores 4. Because in real sense, these are being treated like the way the compiler treats other normal variables or elements. The only difference is that these are a part of a single array, but each of them has its own index. Full stop. So as long as you're able to identify which element is where, it becomes easy. Now, if you look at this statement, we are repeating student scores 0, student scores 1, student scores 2, etc. Cumulatively, the results are being assigned to a memory location called sum. In addition, if you were to add all the elements of a multidimensional array, one at a time, we'll just do it as the way we have done for one-dimensional array. But that will be a very long statement if the number of elements are very many. For example, for us to add all the 25 elements in our two-dimensional array, we'll do it as like this. So this is our array. That's our array, the two-dimensional array. Now you can imagine us having each of these elements like this, or adding each of them separately as follows. So we are assigning one of them to memory location called the sum. And then what are we assigning there is student scores 0, 0 plus student scores 0, 1 plus student scores 0, 2 plus student scores 0, 3 plus student scores 0, 4 plus student scores 0, 5 plus student scores 1, 0 plus student scores 1, 1 plus student scores. So we repeat all that for 25 elements. Isn't it that tedious, my dear students and the rest of the learners? Yes, it is tedious. So what are we supposed to do to simplify these repetitions? So in order to simplify the process of repeating array name and indices within an array operation, we just need to process that array using an iterative control structure. This is because processing an array usually involves a loop which goes through each of the array elements one at a time. So we therefore normally make use of a for loop with each dimension in the array having its own loop. Therefore, in a multidimensional array, we make use of nested for loops. Each dimension has its own for loop because the outer dimension will always take you to the inner dimension. So the loops are arranged from the outer dimension to the inner dimension. Therefore, if, for example, we have three-dimensional array declared as, you can see, we shall make use of three nested for loops to process each dimension because when we are seeing in first dimension here, we have 5 elements for first dimension. So we have, before we move on to the next dimension, it simply means that we have to repeat the same activity for 5 number of elements in the first dimension. And then we change from first dimension, we increment to second dimension. And then we repeat the process for the 5 elements in the second dimension. And then we improve or we move on to that dimension. And then we process the 3 elements in the third dimension. And therefore, we are going to make use of 3 nested for loops to process each dimension. That is 4 loops, or 3 loops for each dimension. The counter variable for each loop is determined by the number of elements for each dimension because you are beginning, for example, if you begin with first dimension, you are going to begin, for example, index 0 to index 5. Once you finish, to index 4. Once you finish, you move on to the second dimension. You repeat the same activity from index 0 to index 4. And you go, once you are doing those, you go to another dimension from index 0 to index 2. And therefore, what I'm calling the counter is what determines what is being processed at what point, which index. So it means that for each of the loops, we have to begin with index 0 to the last index, index 0 to the last index, index 0 to the last index. For one-dimensional array that we have learned as student scores 5, our counter will range between 0 to 4. Simply, those are the 4 subscripts, the 5 subscripts, spanning from index 0 to index 4. So we can use that index, the range of the index, as our counter. And then at what point we terminate? When we move one step ahead of our last index. So if we have two-dimensional array, on the other hand, which we have declared, for example, as follows, then our outer for loop will have counter ranging between 0 to 4, being terminated by 5, because 5 will be an element which is not there. 0 to 4 simply means those are 5 values with index 0 to index 4. So once you agree with the fourth index, it means once you move to the next index that is 5, that should terminate it. For in a loop, the same. It's going to range, our elements are ranging between 0 to 4. So it is going to be terminated by 5. So 5 will be the highest value. And the 0 will be the lowest value. So 0 and 5 are our counters. Therefore, due to the fact that the last index in this case will be inclusive, then our maximum index terminating value will not be the last index for the last value. It will be the next subsequent index. In addition, if you have a three-dimensional undeclared, for example, as follows, then our outer for loop, in this case, our outer for loop will range between counter will be 0 to 4, being terminated by 5. Inner one will be 0 to 4, being terminated by 5. And the most inner one, the third one, will be 0 to 2, being terminated by 3. Very important and very easy for us or for you as a student to remember. Therefore, we can compute the sum for our two arrays using for loop as follows. So for our first case where we have initialized our elements, as you can see, then it simply means we are going to repeat addition for each. We move from the 60, we move to the second element, we increment second to that element, fourth element, and fifth element as we process them. So we can first declare the variable for the counter. Always remember you have the initial counter and the last counter. And therefore, when you're using for loop, it's always good to initialize or to not to initialize, but to declare a variable for the counter. In this case, we can call it index. That is going to store our value like 0 and 1 for storing the total because we are going to compute the sum. Remember, counter will always indicate what is the first value, first index, and what will be the last value, which will be reached for the computation to end. So if you're going to compute the sum, it means that we must also set aside memory for sum. Then proceed and decode the for loop for sum as follows. So like in this case is for index 0. So initialize our variable which we have declared as index. Initialize it to 0. Then check if the value in the memory location called index is less than 5. If yes, do the following. Pick what is in the first index 0. And it to whatever that is the memory location called sum. The overall result, assign them back to sum. My dear students and the rest of the learners, I hope you remember what this operator means. This one here. This operator, just as a reminder for those who might have forgotten, it replaces the statement which would be like, for example, sum equals sum plus student scores index. So what it is simply saying, it's a plus assignment operator, additional assignment operator. What it simply does is it helps us avoid repeating the word sum. So how do we read it? We read it as pick the content memory location called student scores index, current index, like 0, and 2, what is the memory location called the sum, and the overall result, assign them to sum. That's what that statement means. So I repeat the explanation of this expression. It simply means, or is as follows, or this is how it works. Initialize index memory location to 0. Check if the value in the index is less than 5. Yes, perform this operation. Then, once you are done, increment the counter with 1 or index with 1. I repeat, pick 0, assign it to memory location we call the index. Then you compare what is in index or find out whether what is in index is less than 5. If yes, perform this operation. Once done, increment what is in index with 1. So if what is index is 0, increment it with 1, meaning it will be 1. Then check if what is currently in index is less than 5. If yes, perform this operation. Once you are done, increment the value of counter with 1. So if what was there is 1, 1 plus 1 becomes 2. Check if what is in the memory location called index, like in this case 2, is less than 5. That is true. If it is true, perform this operation. Once done, increment the current memory location, the value in the current memory location called the index with 1, whatever that is, incremented with 1. So if it was 2 and 1, that becomes 3. Find out, is 3 less than 5? Yes, proceed. Increment 3 with 1, that is 4. Is 4 less than 5? Yes, repeat the operation. Increment the counter with 1. 4 plus 1 is 5. Is 5 less than 5? No. Exit. I believe we have understood how the for loop works. So we can then display the total immediately after the for loop has terminated using an output statement like that. So this, you will just pick what is memory location called the sum and display it out. The following is therefore a sample program for initializing a one-dimensional array with 5 elements. Then displays those elements, computes their sum, and displays the results. So we have our usual program as follows. Then we declare memory location we call the sum, and we assign 0 to 8 for initialization, and another memory location we call the index. Then we declare and initialize our array called student scores with those values. These things I've already explained, so I'm not going to repeat. And then we now write out our values in the array. We initialize the counter that is indexed to 0. Is 0 less than 5? Yes. If that is true, write out the student scores, write out the index of the student. If it is 0, write 0. Or in other ones, I repeat, read what is in the memory location called student scores at index 0. Write it out. Once you write it out and you meet this brace, increment the value of counter with 1 or index with 1. So 0 plus 1, that will be 2. So is 2 less than 5? Yes. So repeat that activity. Display what is in the index, current index. So if current index is 1, scores 1. That will be the second value. Then increment index with 1. Check. So if it was 1, we increment to 2. So is 2 less than 5? Yes. So perform this operation. Once done, increment again the value of index with 1. So 2 plus 1, it will be 3. Is 3 less than 5? Yes. Perform this operation. Display what is in that position. And repeat until the value of index is not less than 5. Then exit the loop. Then to compute the sum is just the same. For loop will work in the same manner. Initialize what is in the memory location called index to 0, and then pick what is in student score 0, add what is in sum. Remember what is currently in sum is 0, so 0 plus whatever is that position index 0, then assign the results to sum. Then increment the value of index. That's what index plus plus means. So increment with 1. Check if that index is less than 5. If yes, repeat this operation. And that will continue until the value of index is not less than 5. And then exit. Then we write out the sum. And that is the end of that program. Now, how would we code this? Or how would our results look like in a C++ program? So let's see. I'll just copy this program, paste it in my C++ program, and then we see how the output will look like. So what I'm going to do, let me start C++ program in my computer. So my C++ program is already here. Microsoft Visual C++ 2010. So I'm going to click on C++. C, let me search for it again. Microsoft Visual C++ 2010 Express. I click it. Then I can click on File, New Project. And then I can click on Win32 console. This process, you can always begin it the way you want in your computer. What is the name of my file? I have saved my file. I'm going to call it. Let's see the name here. I'm going to call it what? Program name, I'll call it array init sum, array initialization for computing sum, array init sum. So let me type here, array init sum. Then I click OK. Then I'll follow the process. I'm not really going to explain this process because I've explained in my previous presentations. You just wait. Then here, I click here, point on and, click new item, click on the code, C++, write the name again of the program. The one which you have written first was for project. This one is for the program. So it is array init sum, and click on and. Now what I'm going to do, I'm going to copy my program just as it is and paste it here directly for the sake of time. So this is my array. This is my program. This is my program here. Array init sum. Remember, you can code or just copy my program directly from the PowerPoint presentation and you write it in your exercise book or code it in Microsoft Word, like this program of mine. So I'll just copy my program that I've already coded, then paste it in my C++ program here. So paste. You can always type your program directly on the editor or just type it, for example, in Word, and then just copy it and paste on the editor like I've done. Then click on Save to save your work. Then click on Build, and then click Build Solution to run the program. That is to compile the program. You can see that my program has no errors. It has succeeded. So my dear students and the rest of the learners, if you copy the program that I've already displayed the way it is, and you are free to write yours, you can be assured that it will not have any errors. And if you find there are any errors, you just look at my code and debug yours. But what is important is for you to know how you can write your own program. So from there, once you have compiled the program and it's successful, you click on debug, That is for Visual Studio 2010, and then start without debugging, because already our program has no errors. Now you can see our output here. Our program has computed the values directly because already they had been initialized. And you can see this for loop here has written out our 4 elements, our 5 elements. And you can see how the elements were in the array. Is 60, 40, 11, 18, 95. And I've been able to write them out using this statement here. Here are the 5 elements from the array. That is this statement here. And our values have been written out. And the cursor has written a blank line after displaying the values, as you can see. And then from there, my program has computed the sum. That is, as you can see here, computation has been done, and this is the statement which is being displayed at the bottom here. The sum for those elements is 224, and you can see that the press indicate to continue is below there because of this operator, which is at the end here, next to displaying total. And that's how we code a program, having elements initialized for one-dimensional array. Let's see for two-dimensional array how it is going to look like. Now, once you are done, you can always close the solution. And of course, that is closing the program. So you can see that's this is our program, and you have seen how the output looks like. What about now for the two-dimensional array? So this is the program, or this is the array that we want to initialize in our program. Now, we can proceed as follows. You declare the variable for storing total, just as we have seen for one-dimensional array, and then 2 other variables to serve as counters. Remember, we have 2 for loops, the outer for loop and the inner one. So we need to have 2 counter variables. And in this case, I'm calling mine the outer index and the inner index. You are free to call yours the way you want, but remember you need 2 counters to control the limits for each of the for loops. Then we proceed to compute our sum using the for loop as follows. Like, because we have 2 for loops here, we have the outer index. So we initialize the counter for the first pass, the outer for loop. We initialize to 0. And then we move inside there. Or before you go there, let me explain properly what it means. Now, assign 0 to the memory location called outer index. Then check if the value in the memory location called outer index is less than 5. Of course, beginning is 0. So 0 is less than 5. If that is true, move on. And then initialize the memory location called index with 0. Then check if the value in memory location called index 0 is less than 5. Yes, that is true. Remember, already our value in first outer index memory location is 0. So that's index 0. And then here, inner index is 0. So index 0, and here, this is 0, 2. Remember, these are two-dimensional array. So we now perform the computation for the student or the score, which is in the array called student scores, outer index, inner index. Outer index is 0, 0. So this is the first score. Assign or add that value to memory location called sum. And then the overall result, I repeat the statement. Pick the value in the memory location whose index is 0, 0. Add that value to what is in the memory location called the sum. The overall result, assign them back to sum. And then increment the value of inner index. So 0 plus 1. 0 plus 1 is what? 0 plus 1 is 1. Check. Is 1 less than 5? Yes. Repeat this process. When done with this statement, increment the value of count again. So 1 plus 1 is 2. Is 2 less than 5? Yes. So pick what is in students called 0, 2. Then add it to what is in sum. Store the results in sum. Then increment in index again with 1. Is 1, 2 plus 1 is 3. Is 3 less than 5? Yes. So, and the score, which is in index 0, 3 to sum. Then increment in index again with 1. So 3 plus 1 is 4. Is 4 less than 5? Yes. So pick what is in student scores 0, 5 or 0, 4, 0, 4. Then add to sum. Then increment count again in an index. So 4 plus 1 is 5. Is 5 less than 5? No. So it will skip this and find out this brace, and therefore go back again. Increment now the value of outer index with 1. So that will be 0 plus 1. It will be 1. Is 1 less than 5? Yes. Move on. Now, what is in the index now? It will not begin again with initializing in the index again. It will go to next, finding out. Or it is going to initialize in the index again to 0. So, but remember, the outer index is 1. So it is what is in index less than 5. Already, 0 has been assigned to in index. So is 0 less than 5? Yes. So it will come here. Pick what is in which memory location? Outer index 1, inner index 0. 1, 0. And repeat the entire process until inner index is not less than 5. Once inner index is not less than 5, it will come out of that loop, go again, increment outer index. So if outer index at 1, 1 plus 1 is 2. Is 2 less than 5? Yes. It will go back, initialize in index with 0. Check if in index is less than 5. Do the not the usual. Continue until the inner index is not less than 5. Then go back again there. Increment outer index with 1. Check. Is the value of outer index less than 5? That will continue until when the value of outer index will not be less than 5, and then exit. So that's how the counting is going to be done. So we can then display the total immediately after the last for loop has terminated using an outer statement as just we have done for the other one. So the following is therefore a sample program for initializing a two-dimensional array with 25 elements, then computes their sum and displays those elements, including their sum. Displays all of them. So that's my comments. My program is array init sum, just like the other one, but these are 2D array. But even call it 2D array init sum. And then the normal parts remain. Remember, we declare two counters at the sum, and then this is our array initialized, and we initialize it fully. We initialize it fully like that. That's a complete array. And then from there, we can display the values. Here are the 25 scores. Remember, we use them just as we have done for the other one. So this is our for loop here. So it's going to display or write out what is in the scores 0, 0, increment counter to 1, check if 1 is less than 5, yes, then get the scores 0, 1, then increment again, get scores 0, 2, 0, 3, 0, 4, 0. Once 0, 4 is reached, and the inner index becomes 5, then that part will terminate, and then it will increment outer index with 1. So 0 plus 1, that will be 1. So is 1 less than 5? Yes. So initialize inner index with 0. and then display what is index or what is index 1, 0, 1, 0. Then increment in index, and that will continue. The loop will continue until the outer index is 5. So is 5 less than 5? No, exit. To compute sum, the same happens. We are picking what is in the inner index, what is in the 0, 1, we add to what is in the sum, and the result we store in sum, and we continue incrementing inner index until it is not less than 5. And once that is done, we are doing that fast pass, we move the next, we increment outer index with 1, check if the value is less than 5, and then go in again, repeat initialize index, inner index with 0, check if that value is less than 5, perform the activity here, then increment inner index with 1, it will become 2, or it will become, for example, 1, check if 1 is less than 5, then after the operation, increment inner index again, and that will continue until inner index is no longer less than 5, meaning it is with the 5 elements, and then move again, increment outer index, and that will continue until outer index is no longer less than 5. And by the time that brace is reached, the sum will have been computed. And then we display our result there. Then we take back the control to the compiler and we enter our program. So how do we code? How do we code this program in C++? So this is what we do. I'll just copy it and paste so that we're able to see the output, because the way we code, this is the code already. We just need to copy this code. This is the code. So I'm going to copy this code and paste it in my C++ program so that you can see how it will look like. So what is the name of my program? It is array init sum. Now this one is for 2D. So I'll call it array 2D init sum. I'll modify that name, and you're also free to modify yours. So let's go to C++. We paste this program there. So this is my C++ program. I will start a new project. I will click there. I'll click there. I'll call it array 2D init sum. That means it's a 2D array initializing the values and generating sum. That's just my name that I've called. Then I can proceed. Then the name of my file, I want to create a new file. So add new item. It's the code which I'm adding, and that's a C++ file. So again, type array 2D, that means 2D, two-dimensional array, init sum, that is initializing values, then computing sum, and click add. So once I'm here, I'll just copy my program and paste it there. So I'll copy my two-dimensional array program and just paste it there as it is. So here it is, the program that I've already explained. Here it is. So just copy this program or this code, this source code. I paste it in my editor screen like that. And then I can click on save, click on build to compile. Let's see if my program that I've already displayed has any error. Good. Doesn't have any error. It is successful, as you can see here. And therefore, this is how you code your program, and you can see. So I'll click on debug, then start without debugging because I want to execute my program. Now you can see I've been able to display, this is the array, and you can see my program, this part of code here has been able display the values as they are. You can see this is the array and this is the output. Here are all the 25 elements from the 2D array in rows and columns. That is this statement here. And you can see the for loop here has been able to pick all these elements one at a time, and they have been displayed here. And then to compute the sum, there we go. This is the for loop that has computed the sum. And you are free to copy it, just as I've explained. And then this is a statement which is being displayed. The sum for those elements is the total. And that's how this program, our 2D initialized program or initialized array, is working. You can always close your program once you are done. Let us now see how you can initialize elements in the program instead of initializing them within the code. The array elements can also be initialized by the user during the program execution, whereby the program prompts the user to enter elements for the array through the keyboard. The difference between initializing an array during declaration, as we have seen, and initializing during program execution is that initializing during declaration restricted the values for the array elements, and those programs cannot allow the user, and thus those programs could not allow the user to enter their own elements. So during the coding process, the programmer makes use of for loops for reading the values into the array, for performing tabulations with the array elements, and also to display the array if need to be. So the following are therefore our two modified programs. Simply the same program that I have demonstrated. So the first one is a one-dimensional array program that prompts the user for 5 scores, displays the elements, compute their sum, and displays the total. So that's my code there. We know that. We are used to that code. That's the main program part. I'm declaring index just as the other program. In fact, the difference between this program and the other one, which we have already seen with initialization, is that this one now does not initialize the array. It only specifies that the array is called student scores and it has 5 elements. And those elements to be stored in it are of type integer. That's the difference. And then the next is now to request the values from the user. That's what this statement is doing. And then within those values, using for loop, you can see in student scores equals 0. So it will int 0. It will pick the first value to be entered and store it in the memory location called student scores 0. Then increment index with 1. So 0 plus 1 is 1. Is 1 less than 5? Yes. So read the next value and store it in student scores 1. Then once that is done, increment value of index. So 1 plus 1 is 2. Is 2 less than 5? Yes. So repeat this process. Then increment counter, that is index. 2 plus 1 is 3. Is 3 less than 5? Yes. So perform this activity again. Once done, increment index to 4. So is 4 less than 5? Yes. So it will repeat this activity. It will read what has been entered and store it in memory location called student scores 4. So increment current value of index. So 4 plus 1 is 5. Is 5 less than 5? No. So it will skip this part and write out a blank line. And then to display the values now that have been entered, it's just a repeat of the same using for loop. But now we have the C out statement. Yeah, so to write out index scores, student scores index 0, after writing increment to 1, index to 1, is 1 less than 5? Yes. So write out again, student scores 1. Then increment counter again. So 1 plus 1 is 2. Is 2 less than 5? Yes. So pick student scores index 2. and continue until index contains value which is not less than 5. And then to compute the sum is the same. So initialize index 0, index with value 0. Check, is 0 less than 5? Yes. So pick what instrument scores 0, add it to whatever is that is memory location, record the sum, and the results assign them to sum. Then increment the value of index. So 0 plus 1, it becomes 1. Is 1 less than 5? Yes. So perform this operation. Pick what is in student scores 1 and to what is in sum. Assign the results to sum. Increment index again. So 1 plus 1 is 2. Is 2 less than 5? Yes. So pick what is in student scores at index 2. And that will continue until the value of index is no longer less than 5. And then it will now write out the total and return the control back to the operating system and end the program. Let us copy this program the way it is. We paste it in our program and see how the output will look like. So what is the name of our array? Let's see. The name of our program, not the array, but the name of our program. So our program is called array1d init user sum. Array1d init user sum. That means one-dimensional array for initializing the values from the user and computing sum. Array ID. Array ID init user sum. Array ID init user sum. So let's start a new project here. It's with data 2. Then give it that name. Array 1 array 1d init user sum. Click OK. Then continue. And then and our program, our source file is code C++. The name of our file is array 1d init user sum. And then we click on and. Now let me copy my program the way it is in my document here. So I just want to copy this program just as it is. That is array 1d init user sum. Just as it is, as I've explained, I will copy it there. And then I paste it on my editor. There we go. Save the program, then build the program. Let's see if my program has any errors. You can see there are no errors. So I can run my program. The purpose of running this program is to enable you to see how the program is working. So the first section is here. We are being told enter 5 scores in the array. That is this statement. So you can see the for loop is there. The for loop is there. So let me enter 23, 45. Let's see if we do terminate after entering the 50 value. So we can see now the output part is here. We are being told here are the 5 elements for the array. You can see the array, the list is there. But now, after typing, you can see they have been written out in one row. That's a one-dimensional array. And then the sum has been computed. Where is that section for sum? There's this one here. You can see the for loop has been able to compute the sum of those elements. If you add 23 plus 5 plus 56 plus 34 plus 12, it will give you 170. So that's how our program is different from the one for initializing because this one is prompting for the values. So we are done. I'll close that. And then let's proceed and see how we do it for the two-dimensional array. So the following is 5 by 5 two-dimensional array program that prompts the user for 25 scores that are entered into their respective index in memory, then displays the elements for the array as arranged in memory, computes their sum, and displays their total on the screen. Now, look at this program. Why am I having arrow manip there? It is for the purposes of spacing my characters when I'm outputting. And then, of course, the other parts are the same. You can see, just as I've explained, this presentation, you have to declare 3 variables. One is outer index and inner index for counter. Then we have sum. Our array now is not initialized. We are only declaring, and we are telling the compiler, this array is a two-dimensional array, and its name is students scores, and is going to accept values of type integer. Then from there now is to request the user to enter. So the user will see this statement, enter the elements of the 5 by 5 two-dimensional array in row major order as per index that will be displayed. Then I have index there. Now, how do I display the index? This is what will happen. Remember, I have 4 loops, and the first counter is outer index. I initialize it to 0, then check is value of outer index less than 5? Yes, perform this activity. Initialize the memory location count index to 0. Check is 0 less than 5? Yes. So do the following. Write out this square bracket and then pick the value in the memory location count outer index. Pick that value followed by this pair of these operators or these symbols, and then the inner index. So like in this case, the first one will be 0, 0. Because outer index is 0, inner index is 0. Then do the following. Prompt the user to enter a value, which will be entered in memory location called students scores, which index 0, 0. Once that is done, increment the inner index to 1. So is 1 less than 5? Yes. So read now or request the user or write out a 0. Remember, the index has not changed. It remains 0. So 0, 1 right there. And then read value and enter it in memory location called student scores index 0, 1. Then once you have done that, increment in index with 1. So 1 plus 1 is 2. Is 2 less than 5? Yes. So write out 0, 2. Okay? And then read what is in, read the value that will be earned by the user and store it in memory location called 0, 2. So you can see the inner index will continue changing until it is 4. And once that is 4 and inner index is incremented by 1, becoming 5. Is 5 less than 5? No. So that inner loop will terminate, and then the program will repeat or increment the value of outer index with 1. So 0 plus 1 is 1. Is 1 less than 5? Yes. So move into the inner index. Initialize 0 inner index to 0. Is 0 less than 5? Yes. So repeat this activity again. Repeat the whole activity again. The whole activity again until the value of inner index is no longer less than 5. Then move out of that inner loop. Increment the counter outer index with 1. So if it was 1, make it 2. And that will continue until outer index is no longer less than 5. And that loop will be terminated. And then from there, a new line will be displayed on the screen. Then to display the values, we just use the same order. That's how our for loop, the inner for loop and the outer for loop will look like. And the only difference is that we are writing out the value C out. We are writing out. So beginning with 0, 0, 0, 1, 0, 2, 0, 3, 0, 4. Then outer index increments to 1. So 1, 0, 1, 0. 1, 0, 1, 2, 1, 1, I repeat, 1, 0, 1, 1, 1, 2, etc. Once the outer inner index is no longer less than 5, you come out, increment outer loop, and that will continue. The values will be being written out in that order. Now to compute the sum is the same. The only difference is that now we are reading the values and adding to memory location called sum, and then assigning the value there again. In other words, we are reading the value, adding to what is memory location constants cost, and assigning the same to the memory location. And that will continue until all the values have been read and computed. And then from there, we display the results. The control is taken back to the operating system and the program ends. Let me copy this program. I hope you have seen the program the way it is. When you are copying this program, you can always pause. You pause my presentation, copy the code, move to the next screen, copy that code, and then you can code it directly in your editor, or you can just type it in Word or any other editor, and then you just paste it there. So let me go to my C++ program, and then we start a new project. Remember, our program is called what? It's always good to remember the name of my program. So my program, I'm saving it as, the name is array2d, user init sum. So I'll go to my C++ program, start my new program, my new project, this win32, and then the name of my project will be array2d init user sum. That's the name. You can give yours. And then you follow the procedure that you have been following before. Then add my new program there, or my new source code. Select there. The name of my project file source code is array2d. Let me repeat. Let me cancel that. I repeat this code, C++, then select here. It is array2d init user sum. That's the name I'm giving. Then I'll just copy my program and paste it there. For the two-dimensional array, here it is. So just copy the program that I've already explained. I'll copy that, and then I paste it on my editor here. So that's my program. Remember, you can copy this program and save it. And once you have learned how to write it by yourself, you can always develop yours. Then once you have coded it in your editor, you save. Then to build, remember you can compile in other versions in different ways, like clicking on the compile or clicking on the sum may have another different menu, but then look for build or compile your program. So I've clicked on build. Let's see. Now my program must be successful. There is no error. So I can click on debug, start without debugging. This means running. So in your version, you may have it as run. Now you can see how my output screen is looking like. This is the part which has been displayed. Enter the elements of the 5x5 two-dimensional array, major in row major as per the index displayed. And this is the heading, index in memory. And just as I explained, you can see that I have the for loop for the outer and the inner, and it is writing out this part first. So the first is index 0, 0. So you just type, then it increments the inner index to 1, then increments to 2, increments to 3, increments to 4. Then you can see the outer index are changed to 1. It has been made 1. The inner index to 0. So you can see the inner index is 1 which is changing. The outer index is 1. You can see the inner index is done. So we have gone to the outer index for loop with the outer index. And now it has been incremented to 2. But inner index is 0. So we enter the values. You can see the inner index is the one which is changing. The inner index is the one which is changing. Then the outer index has been incremented. Inner index is the one which is changing. Outer index has been incremented to 4, inner index to 0. You can see the inner index is being incremented until the value of index is more than required. So lastly, we have been able to display our array. So this is the part which is being displayed now. This is the section here. And you can see how my values are looking like. There is that set W that you can see, which I've added as a function here for displaying the values. You can see there is the spacing there where I've said see out set W7. This is purely for spacing, and you can see my output, how it is looking like. That is this part of code. This is the part which is being displayed, and you can see how my output is looking like. So I have entered the values, but they are now organized in a 5 by 5 two-dimensional array. Then after, you can see at the bottom, the sum has been computed. So this is the part which has done the computation. That's the part which has done the computation, as you can see. And the total has been displayed just as see out. The sum for all the elements in the array is good. So that brings us to the end of our two-dimensional array. And with that, my dear students, it's good to note that this is my complete program. We have displayed the values. You have seen even the purpose for the function set W and how it is working. Then we have computed our values, just as I've explained using the for loop. And then we have been able to execute the program. We have been able to compile it, and we have seen what it does. And with that, therefore, we have come to the end of section 1 of 2 on arrays. You can then proceed and listen to part 2, that is section 2 of 2, or part 9 on how we process arrays. In this tutorial, we have learned how to work with arrays, how to manipulate arrays, how we go about them, and even how we can be able to manipulate them. What is remaining is for us to know how we pass the array to a function, how to sort arrays, and how to search arrays. And that is what I have presented in the next presentation by the title, Part 9, Section 2 of 2 on processing arrays. Congratulations, therefore, for learning Part 9, Section 1 of 2 in C++ computer programming series by the title, Introduction to Arrays. You can access the rest of the parts in the series, as well as other computer or ICT videos by clicking or tapping on Emily Swap ICT YouTube channel below this video. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write it to us through the email emilyswap@gmail.com. Thank you very much for listening to me. Let us meet in the second section of part 9, and may God bless.